Hey kids, welcome to lesson 1, Buttons and Events, part 6. These next couple of lessons all deal with debugging, so we're going to handle them all together. There's two things I really want to talk about before we get started. And this is the two types of common errors you're going to see out in the computer science world. I promise you, this isn't all of them, but these are the two most common. The first is a syntax error. If you're a desktop person, you've probably come across this many times. This means the computer does not understand what you're trying to tell it to do. It is a blank stare back at you saying, I have no idea what you mean. The other type are logic errors. And logic errors are a lot more tricky. This is because the program will actually run, but it's just doing something wrong. For example, maybe you have a move forward and turn right swapped. So anytime a person would click the move forward, they would turn right and vice versa. So in that instance, the program is running, it's just not running correctly and the computer doesn't know that. In that case, those are a little harder to catch. With syntax errors, the nice part is though, you do get a little pop-up message that tells you something is wrong. So with those two things in mind, let's jump into our lessons and see what's going on. Let's read our directions for our first one. Debugging event-driven program IDs. You try it, checking IDs. Your first debugging task will be to verify that the button ID matches the event handler. You'll see an error message in the debugging console. The debugging console is this down here by our turtle and rabbit. As a little heads up, you can hit this little arrow to make it go up or down. We're going to keep it up because we're going to need it. Here's a little example right here. So what are we going to do? We're going to run the program and inspect the error message in the debugging console. Note, an error message only indicates where the computer ran into trouble. It doesn't tell you the root cause of the problem. We're going to investigate, use the error message as a clue to investigate the possible problems. We're going to fix it. We're going to make a change that we think will fix the problem. And then we're going to run the program again and verify that it works correctly. Didn't work? Rinse and repeat. We're going to go to the steps above here and work our way through the problem-solving process again. Remember, you can see the ID of a UI element by just hovering your mouse over it. That's what it's talking about right there. So you see if I hover over it, it says ID forward with a lowercase f and a capital case B. Let's go ahead and hit run and see what happens. Well, I do get a warning. It says line 1, on event ID parameter refers to an ID button 1, which does not exist. Well, hovering over here, let's hit reset here. Hovering over here says my ID is a forward button. It's not button number 1, so I think that's my first issue. Let's go down here. There's two ways we could fix this. We could actually go to design, change the ID right there. Or the much easier way, we could come over here to the event. The first one is our ID. If we click down, forward button is it. Let's hit run, move forward. There you go. So it was just a ID that didn't exist. This is a very common problem, especially when you get into very complex applications. When you have 20, 30, 40, 50 things running, it's very easy to forget or just name something wrong. So that's a good first thing to look for. That is it. Everything is running good. Let's go ahead and see what the next one says. Debugging event-driven programs, IDs. Try another one. This one is a little trickier, but very common again. Ooh, I do like trickier. Down here, we have our problem-solving process right here, or run the program, investigate if there's an issue, fix the issue, run the program to verify that it is working correctly, and repeat if necessary. We have a little hint right here, but I think we can figure it out without it. Down here, we have our program. It says right now, forward button click, move forward, left button click, turn left. Over here, I have a go forth and a left button. Let's go ahead and run and see what happens. We'll go forth is working. Ooh, line number 4. On event, ID parameter refers to left button, which does not exist. Let's reset this. And this says left button. Down here, it says left button. Ooh, spelling is important here. This one is left with a capital B button. Down here, it's just left button. Let us capitalize this B. Run the program again. No errors so far. Go forth, seems to work right. Turn left is turning the turtle left. No errors. I think that's all we had to do. So this one was just as simple as one letter. Again, can you imagine if you had to look through hundreds of lines of code just to find one letter that wasn't capitalized? So double check this stuff as you do it, and this is why it's important to give it meaningful names. Debugging unexpected behavior. Predict, observe, reflect. To understand a new piece of code, good programmers often try to make a prediction about what the code does before running the program. By forcing yourself to make a prediction, it doesn't matter if you're right or not, you're immediately alerted to any unusual or unexpected behavior, and you can ask yourself, why did it do that? Was it supposed to happen? It might not be an error, but you will gain invaluable insight and actually learn faster. Predict. For the code that is here, what will happen when the forward button is clicked? We are going to study the code here. The program has two event handlers listening for events on the same button, and force yourself to make a prediction. And I don't know is always a valid prediction. Here are some things to think about. Will there be an error in the console immediately after hitting run? Will there be an error on the console but not until you hit the button? The program does nothing. The turtle only moves forward. Turtle only moves left. Turtle moves forward, then left. Turtle turns left, then moves forward. Something else? Observe. Once you've made a prediction, close these instructions and run the program to observe what happens. Reflect. Was your prediction correct? If not, what about your mental model might need changed? Talk about it with a classmate and experiment with the code to make sure you understand what is happening. So it looks like here we're going to make some predictions and then run the code. Let's take a look. I have a forward button here. And over here in my workspace, I have two events. Each are calling on button 1. This right here is button 1. And both when clicked, will move forward and turn left. On event button 1 clicked, it'll move forward 25. But also when button 1 is clicked, it'll turn left 90. Well, what I think is going to happen is the turtle is going to move 25 pixels up and then turn left 90 degrees. Let's see what happens. Program's running. Forward. Ooh, that happened fast. Let's slow it down a little. Reset, run. Forward. There you go. Move 25 pixels up, turn left. So I was correct. Let's think about this a little. Now, I don't know whether or not this is what the coder intended to do. This could be exactly what the program was meant to do. I have two hypotheses, though. First is one of these types here are wrong. So maybe the coder intended on button 1, a mouse down, something happens, and then a mouse up, something else happens, or maybe a mouse over, something like that. Second hypothesis is this is exactly as it's intended to be. The turtle is supposed to move forward, turn left 90. Though I would argue that's a little clunky and you could accomplish the same thing by just moving that up there. Either way, we were right about the code, what it did with the turtle, and I think we learned a little. And I feel pretty confident moving on. Well, we've come to our last little problem here. Too bad, I was having lots of fun. This one is going to be a logical error. So the last three problems we did are syntax errors, and we are going to try a logical error now. Let's see what's in store for us. Sometimes you can write a program that generates no errors, but still does not work as intended. This is the result of logical errors in your code, and making a prediction can help you find these nasty little buggers too. Once again, we've introduced an error, or two, a logical error this time, for you to debug. Looks like below that we have the problem-solving process right here, investigate the code, make a prediction, run the program, reflect, fix it, and repeat as necessary. Okay, let's see what we have here. Let's take a look. In the screen, I have go forth. Looks like I have an ID of button 2. I have a turn left button, which is an ID button 1. If I come down here on the event that button 1 is clicked, it's going to move forward 25 times. On the event button 2 is clicked, it's going to turn left 90. I think when I was up here looking at this, that first ID said button 2. So go forth is button 2. Well, down here, move forward is on button 1. So it looks like this program, while will certainly run and not give us any errors, does not look like these are in the right order. It looks like they are flip-flopped. Let's hit run and see if that's what happens. So run, I'm going to go forth. Oh, turtle turns left. Turn left, goes forward. So we were right. These two are flip-flopped. Let's go ahead and fix that. We're going to change button 2 to button 1 to button 2, button 2 to button 1. Let's hit run, go forth. Turtle's on the right path now. Pretty good. That was a lot of fun. I think we fixed both of our logical errors. So we actually had 2, a little hint there. So we fixed both of them, and I think that's all we had to do. All right, kids, I will see you on the next lesson.